this module, we will focus on the specific National Construction Code design requirements and the terminology used for fire performance. We will look at the requirements of the NCC Section C around fire resistance and the National Construction Code fire terminology for type of construction, fire resistance level, resistance to the incipient spread of fire, and non-combustibility. The prescriptive solutions that are deemed to satisfy the performance requirements for fire resistance are detailed in the National Construction Code under Part C1, Fire Resistance and Stability, Part C2, Compartmentation and Separation, and Part C3, Protection of Openings. Section C of the NCC deals with performance requirements concerned with safeguarding people if a building fire occurs. The objective of this section, as you can see stated here, is to safeguard people from illness or injury due to a fire in a building, and safeguard occupants from illness or injury while evacuating a building during a fire, and facilitate the activities of emergency services personnel, and avoid the spread of fire between buildings, and protect other property from physical damage caused by structural failure of a building as a result of a fire. Section C has two functional statements. CF1, requiring a building to be constructed to maintain structural stability during a fire, and CF2, to provide safeguards to prevent fire spread. Both of these will allow occupants time to evacuate safely, allow for fire brigade intervention, and avoid damage to other people or property. In regards to terminology, Section C1 Part 1 details the fire resistance requirements. In regards to fire resisting construction, the building class, in conjunction with the building height, expressed in terms of the rise in stories, is used to determine the type of construction required. Let's first look at the NCC's approach to building classes. The NCC classifies buildings into 10 classes. Class 1, residential. Class 2, flats, units or apartments. Class 3, such as hotels or motels. Class 4, the residential component of Class 5, 6, 7, 8 or 9 buildings. Class 5, offices. Class 6, shops. Class 7, storage or car parks. Class 8, factories or workshops. Class 9, public buildings. And Class 10, outbuildings. It is Class 2, 3 and 5 buildings that are specifically addressed by the new NCC changes for mid-rise timber construction. A Class 2 building is a building containing 2 or more sole occupancy units, or SOUs as they are commonly known, each being a separate dwelling. For instance, this could be an apartment building with multiple SOUs separated vertically by fire and sound resistant walls and horizontally by fire and sound resistant floors. A sole occupancy unit is defined in the NCC as a room or other part of a building for occupation by one or joint owner, leasee, tenant or other occupier, to the exclusion of any other owner, leasee, tenant or other occupier, and includes a dwelling or a room or suite of rooms in a Class 3 building, which includes sleeping facilities, or a room or suite of associated rooms in a Class 5, 6, 7, 8 or 9 building, or a room or suite of associated rooms in a Class 9C building, which includes sleeping facilities and any area for the exclusive use of a resident. SOUs can be a side-by-side, stacked on top of each other, or adjoining rooms of a different type or space such as a public corridor. A Class 3 building is defined in the NCC as a residential building other than a building of Class 1 or 2, which is a common place of long-term or transient living for a number of unrelated persons, including a boarding house, guest house, hostel, lodging house or backpackers accommodation, or a residential part of a hotel, motel, or a residential part of a school, or accommodation for the aged, children or people with disabilities, or a residential part of a healthcare building which accommodates members of staff, or a residential part of a detention centre. Class 5 buildings are defined as an office building used for professional or commercial purposes, excluding buildings of Class 6, 7, 8 or 9. Let's now look at the terminology around rise in stories. The new mid-rise deemed to satisfy provisions state that the building must have an effective height of not more than 25 metres. This is effectively a rise in stories of approximately 8 levels. NCC Section C, Part C1, Clause C1.2, defines the calculation of rise in stories as the sum of the greatest number of stories at any part of the external walls of the building and any stories within the roof space, either above the finished ground next to that part, or, if part of the external wall is on the boundary of the allotment, above the natural ground level at the relevant part of the boundary. A story is not counted if 1. It is situated at the top of the building and only contains heating, ventilating or lift equipment, water tanks or similar service units or equipment, or 2, it is situated partly below the finished ground and the underside of the ceiling is not more than 1 metre above the average finished level of the ground at the external wall, or if the external wall is more than 12 metres long, the average for the 12 metre part where the ground is lowest. Turning now to NCC terminology and determining the type of construction for a specific building. NCC Volume 1, Section C, Part C1, Table C1.1 designates that the type of construction be based on the class of building and the rise in stories. Mid-rise Class 2 and 3 residential buildings are typically 4 stories or more high and are therefore required to be of Type A construction. Type A construction is the most fire-resisting form of construction, and the prescriptive solutions within the past versions of the NCC impose severe limitations on the use of timber through the prescription of masonry and concrete construction and non-combustibility requirements for other elements. Type B construction, whilst not requiring as high FRLs as Type A construction, applies similar constraints to the use of timber. Type C construction is the least fire-resisting form of construction and places few fire-related restrictions on the use of structural timber members. It is applicable to most low-rise buildings. The NCC also uses some specific terminology in terms of the material performance. In order to adequately specify or check evidence of suitability of fire-protected timber, 3 items of information are required: fire resistance level, or FRL, resistance to the incipient spread of fire, or RISF, and results from a non-combustibility test. Fire resistance level is defined in the NCC as the grading periods in minutes determined in accordance with the specification A2.3 for the following criteria: structural adequacy and integrity and insulation, and expressed in that order. Structural adequacy refers to the ability of a load-bearing element to support an applied load. Integrity refers to the ability of an element of construction to resist the passage of flames and hot gases from one space to another. Insulation refers to the ability of the surface of an element of construction on the non-fire side of the element to maintain a temperature below the specified limits. For example, if an FRL of 90-60-30 was required, the element would need to satisfy the structural adequacy criterion for 90 minutes, the integrity criterion for 60 minutes, and the insulation criterion for 30 minutes. Note, a dash means that there is no requirement for that criterion. For example, 90-dash means there is no requirement for an FRL for integrity and insulation, and dash means there is no requirement for an FRL. The resistance to the incipient spread of fire, RISF, in relation to a fire protective covering means the ability of a covering to insulate voids and the interfaces with timber elements so to limit the temperature rise to a level that will not permit ignition of the timber and the rapid and general spread of fire throughout any concealed spaces. The performance is expressed as the period in minutes that the covering will maintain a temperature below the specified limits. The primary objective for the specification of a resistance to the incipient spread of fire is to reduce the risk of the timber structural elements being ignited prior to burnout of the contents or fire brigade intervention, in the unlikely event of failure of the automatic fire sprinkler system. In order to achieve this objective, it is necessary for the RISF performance not to be compromised by the presence of building service penetrations and openings for doors and windows. Many materials are also required to be non-combustible. A material is classified as non-combustible if flaming is not observed and specified temperature rise limits are not exceeded when a sample of material is exposed to the heating conditions specified in AS 1530.1. To facilitate a consistent approach to specifying the performance of fire-protected timber, the following format is recommended. For describing the fire-protected timber requirements: fire resistance level, resistance to the incipient spread of flame, and NC, describing non-combustible lining materials. So, re-looking at the new NCC clause C1.13 that defines fire-rated timber, we have now examined the different classes of building described in the NCC, and specifically the definition of Class 2, 3 and 5 buildings, and determining the effective height of a building. In the next series of modules, we will now examine in detail fire-protected timber and how this is achieved, the different FRL requirements for building elements, automatic sprinkler system requirements, the use of non-combustible insulation, and the installation of cavity barriers. In summary, in order to adequately specify or check evidence of compliance of fire-protected timber, 3 items of information are required: fire resistance level, FRL, resistance to the incipient spread of fire, RISF, and the results from a non-combustibility test, NC. For further information on wood and wood products, visit woodsolutions.com.au, the website for wood.